Hey, what's up? You're watching Swifty, and in this episode, I'm going to show you how an unowned reference can help you solve strong reference cycles in your code. And we're going to use an example of a customer and a credit card where the customer is going to outlast the credit card. Basically, the credit card cannot exist without its customer. And therefore, the credit card holds an unowned reference to the customer. So like a weak reference, an unowned reference does not hold a strong reference to an instance. But unlike weak references, with an unowned reference, you have to make sure at least one other reference outlasts the unowned reference. Otherwise, your app can crash. Unowned references must reference non-optional types because they are expected to always have a value and therefore doesn't include any safety features to account for referencing a deallocated instance. So your program will crash. Crash if the instance is deallocated. If the instance your unowned reference points or references deallocated. And just to clarify, it'll be a runtime crash. So we're going to model a customer and a credit card, and the difference between the customer and the credit card compared with the apartment and the person is a credit card will always be associated with the customer, while an apartment might not always be associated with a tenant. And because the credit card will always have a customer, we're going to define its customer property as an unowned reference. And because we're using unowned and not weak, we don't have to treat it as an optional type. So let's get started. Here's the customer name, give type string, card, credit card, name, string, self.name equals name, and we're going to give it a dinit. Just going to make this one line, dinit, and print name being deinitialized. And down here, we're going to create the credit card class. Credit card let number equals UI int64 unowned let customer int number UI int64 customer and self.number equals number, self.customer equals customer, and we're going to give this dinit, print number, Alright, and just to note, we used UI int64 instead of int to ensure that the number property's capacity is large enough to store a 16-digit card number on both 32-bit and 64-bit systems, because int is a 32-bit on 32-bit machines, and int is a 64-bit on 64-bit machines, but we need to ensure that it's a 64-bit. So first, let's create a variable called John. We're going to declare it as type optional customer. So now we have John. The value of John is nil, and I can prove it right here. John, and it's going to print out nil. And so now we're going to create an instance for John, an instance of customer. And so now John is going to reference this instance of customer, and we're going to give the name John. Now there's one strong reference to this instance of a customer. Now we're going to give John a credit card. So John.card, and we're going to force unwrap John because we know we just gave him the value on the line just before. And so we're going to create an instance of credit card, and we're going to give the number as 1234 underscore 5. Oh, actually, it shouldn't be a string. So we're going to give the number as 1234. We're going to use underscore, which is basically like a comma that you can put anywhere. Like if you put a comma in a number, then the program's going to crash. It's not going to know what to do with it. However, if you use an underscore, it's an accepted way of creating a number. So underscore 901212 underscore 3456, and the customer is going to be John. And we're going to force unwrap that. It needs to have non-optional customer. So the compiler reads this part first and creates the instance of the credit card, and it sets the customer property on it equal to the instance of John. So it's actually going to point to this instance of a customer, and then it reads this assignment and says the card property on John is referencing this credit card instance. And the customer reference to John is an unowned reference. So I'm going to make this one different color. This customer instance has at least one strong reference from John, and the credit card instance has one strong reference from the customer. So neither are going to be deallocated. Let's say we wanted to deallocate this instance of a customer. What would we have to do? If we remove the unowned reference, it would still have a strong reference, so it would not be deallocated. However, if we have John point to nil instead of this instance of a customer, then customer would be deallocated because there are 0 strong references to the customer. So the unowned reference was basically a gateway for anyone looking up the credit card to access this instance of a customer. However, when John no longer references this instance of a customer, then customer will be deallocated, and trying to access John through this credit card will also will result in a crash. But the credit card itself will be deallocated because once this instance of a customer goes, then the strong reference to the credit card goes as well, and then there will be no strong references to the credit card, so it will be deallocated. So I'm going to put that in code first, and then I'll model it in Sketch. So we're going to set John equal to nil. All right, now when we do that, John points to nil, and because there are no strong references to customer, it's deallocated, and so its reference to credit card goes with it, and then credit card has no strong references to it, so credit card goes away along with its reference, and both are deinitialized, and that's what we see here. As soon as we write John equals nil, so if I comment that out, it's going to go away. If I uncomment it, it'll come back. John is being deinitialized and the card is being deinitialized.